Hi, welcome to this third session of this modulo 3, that is partial differential equations of our class. Today we are going to discuss solution of homogeneous PDE involving derivatives with respect to one independent variable only. So, before going to this, we already discussed in the previous classes how to form a partial differential equation by eliminating arbitrary constant and then arbitrary functions. Then after that, I have to find the solution of PDE by direct integration method. So, that means I have to find out the independent variable with respect to a dependent variable. So, in this class we have discussed only a homogeneous function of PDE involving a derivatives with respect to an independent variables only. So, before going to this, we have to remember one thing. So, whenever if any constant function appear here, so you have to write down in terms of a variable, the constant. Suppose for example, if f is a function of a two variable x comma y, if you are going to integrate that one with respect to x, the constant what they obtain, we have to write down in terms of a variable, that is y, that we have treated that y as a constant. So, this is the thing you have to remember. So, that means suppose the dependent variable has been differentiated partially with respect to one independent variable, say an x. The PDE treated as an ordinary derivative. So, we already know that what is an ordinary derivative. That means one dependent variable, it has one independent variable. I have to make the equation in that form. Here the arbitrary constant in the solution are then replaced by an arbitrary function of the variable y. By giving, it will give the solution of a PDE. So, we are going to see some more example how to solve the problem, the PDE by an independent variables. So, let me start with the first problem. So, here a solve, the problem will be given, here solve a dou square z by dou x square plus z equal to 0. So, here some initial condition will be given. What is that initial condition? When x equal to 0 and z is e power x, and also the first order partial derivative dou z by dou x, that value is also given, we treat it as an 1. This is the problem will be given. So, here we treated as z is your dependent variable and x is a independent variable. So, here z is completely, it is a function of x only. So, formation of PDE, that is a partial differential equation, by assuming in the form of an ODE. So, that means we have to convert this one in terms of an ordinary differential equation by taking some substitution. So, both a dependent variable is there now z here. So, I have to assume this one as an ordinary derivative by assumption of this one. It is a d square z by dx square plus z equal to 0. So, we know that in the previous semester how to solve this ordinary differential equations, especially in the second semester, by making an auxiliary equation. Now, to form the equation in the form of an auxiliary equation by taking some substitution here, I have to assume a substitution by using a d operator, that is d is a d by dx. I have to use the solution. So, this is the d operator, we are using a d by dx, that is simply called as in d. This ordinary equation will be like that, d square z plus z should be equal to 0. Now, take a common factor of this z, we have d square plus 1 of z equal to 0. Now, equation are entirely reduced in terms of a polynomial equation. We know that how to evaluation the polynomial equation. So, just have to consider an auxiliary equation, or simply I am writing here AE, it is an auxiliary equation. If you want an auxiliary equation, I do not want your dependent variable z here. You send it here RHS, this by 0 by z they become a 0. Now, we have only an ordinary equation, a polynomial equation up here in this form, d square plus 1 equal to 0. Now, send this term to right hand side, we have in minus 1, then d equal to, it is a plus or minus a square root of minus 1. We know that inside any negative number appears, inside the square root, it is an imaginary. So we can write down this as an plus or minus I. The complementary function, it is an homogeneous, and we have only a complementary function will be appear here. The complementary function for this particular function is simply we call as an yc or z. It is z is your dependent variable. Here z is a complementary function, is a cos x c1 cos x plus c2 sin x. So this is the complementary function we are obtained only for ordinary differential equation. We should convert the solution in terms of partial differential equation by assuming the constant c1 and c2 in terms of a variable. So here z is a function of x. I am going to convert in terms of another variable y. So this is the solution for ODE. The solution for PDE, just you have to replace c1 and c2 in terms of a function that is in y. The solution for PDE, so I am writing here now, the solution of PDE, that you have to replace c1 and c2 in terms of a function that is a y. So simply I am writing z is a function of f of y into cos x plus, then other can call some other variable that is g of y, this arbitrary function. So this is the complete solution of PDE in terms of an complementary function. So now I am going to find out the value of this is f of y and g of y by using an initial condition. So here the initial condition will be given in the problem. So this is the initial condition. In both the cases z is in e power x and the derivative of z with respect to x, both the value will be given. So if these both the values are given when in both the cases we are treating x as a 0, that you have to substitute in the equation 1. Then respective values of f of y and g of y will be obtained. In the first case, now I am going to take in the first case. In the first case I am taking here z, so I am writing here now case 1. So simply we can call here z is 0 and x is also 0. These two cases will be given. Now I am going to substitute in equation 1. If we are going to substitute these two in equation 1, we have z value is 0. Now substitution in equation 1, this value becomes 0 equal to then f of y, then now substitute here cos 0 plus g of y into sin 0. You know the value of cos 0 and sin 0. The sin 0 value is 0. Then after that multiply 0 with g of y, the entire term becomes 0. Then after that we know the value of cos 0. The cos 0 value is 1 and 0. This is an f of y into 1 plus g of y into 0. The 0 multiply anything term is be 0. Then f of y into 1, we have in the first case, first initial condition will give the value of f of y. And the second condition is also given here now. That means in the second condition we are going to extract the value of g of y. If you want to extract the value of g of y, you should use the second condition. In the second condition here in the given, here dou z by dou x, this value is 1. In this case also we are treated the x value as a 0. So see here your equation 1 are obtained in terms of z. The solution will be given in terms of a derivative, that is dou z by dou x. I wanted to dou z by dou x using the equation 1. You have to differentiate the equation 1 with respect to x. You are going to differentiate this one with respect to x. Equation 1, differentiate partially equation 1 with respect to x. If we differentiate this one partially with respect to x, we get dou z by dou x, and f of y, it is a constant with respect to x partial differentiation, it is a function of y keeping as it is. but the differentiation of cos x with respect to x, this become minus sin x. Then plus g of y, the derivative is sin, again it is a cos. Now use this condition, dou z by dou x value is 1, you put it here now, and the same way I have to put the value of x is also 0. Now substitute here, this is 1, then f of y minus sin 0 plus then g of y into cos 0. I already told in the first conditions here, the value of sin 0 is 0. If any term having a 0, then multiplied with any one function, they automatically they become 0. Then 1 equal to this term entirely 0, because sin 0 is 0. 0 multiply anything is 0. Then you can write down 0 plus cos 0 value is 1, then g of y. So your g of y value is 1. So here now in both we get the value of f of y, then g of y. Now after that, if you are getting that, now I am going to substitute in the equation. So substitute these two values in g of y and f of y in equation 1, we get the required solution. The required solution we have obtained here now. So substitute g of y value is 1, then f of y value is 0. The multiplication of these two, we get finally the z value. The z is, I am going to write down, this is 0, then this value is 1. So we get sin x. So this is the required solution of the given equation. So this completes the first problem. Similarly, we are going to for the next problem. Now move to the second problem. So again I have to use the second order derivative, that is dou square z by dou y square equal to z, and the given condition will be given y equal to 0 and z equal to e to the power of x, and dou z by dou y should be equal to e to the power of minus x. This is the problem will be given now here. So again it is a second order dou square z by dou y square equal to z, and given the condition y equal to 0 and z equal to e power x, and dou z by dou y equal to e power minus x. This is the condition will be given. So as usual we are done in the previous problem, I have to do the same thing here now. So here z is a function of y only, and here also some dependent variable also given, it is a z. So I have to write down in terms of an ODE by take a substitution like that. So I have to write down it's a ODE d square z by dy minus z should be equal to 0, where we are going to convert in terms of d operator. Simply you can write down d by dy d, it is a d operator. Then after that, now substitute here now d square z minus of z should be equal to 0. Now take a common factor of z, we get d square minus 1z equal to 0. So your auxiliary equation, then auxiliary equation reduced to d square minus 1 equal to 0, then d square equal to 1. Now send the 1 to other side, it become 1. Then I wanted to d is plus or minus square root of 1. Then d value we have plus or minus 1. Totally d is 1, then d equal to minus 1. Now these two are real roots with a different form. So this is real and different. So in this case, the solution for ODE, here z equal to, z is in your dependent variable, z equal to c1 e power x, then c2 e power minus x. So this is the solution we get in terms of an ODE. Now I am going to convert this one in terms of PDE. Whenever I go to conversion of this one in terms of PDE, sorry, you have to remember one thing. So these are both are, it's a function of y, I have to put it here now, minus y. Now here z is a function of y only. So the solution is also obtained for ODE in terms of y. Now I am going to convert this one in terms of a variable by replacing the constant with of x. So that's why I am going to write down here now. Now here z equal to, this is the solution for ODE. Now I am going to convert this is f of y, it is a function of constant, then e to the power of y plus then g of f of x, then g of x, then e power minus 1. So this is the solution for PD. Now call this as an equation number 1. Now I am going to extract the value of f of x and g of x. So using the initial condition, this is y equal to 0 and z equal to e power x, then again derivative of z e power minus x. Now using this initial condition x to extract the value of f of x and g of x. In the first condition, the given, in the firstly the given the value of z is e power x and y equal to 0 in equation 1. Now substitute in equation 1. The substitution of this one, what happened, we are going to find out here now. See here, I am going to substitute this e power x here now. The value of z is e power x, and also you put the value of y equal to 0 in this here. It is an f of x, then e power 0 plus g of x, then e power 0. We know that any function, any variable having a power 0 or any function having a power 0, that value is 1. So e power 0, these two values treated as 1. Then we have e power x equal to f of x plus g of x. Now call this as an equation number 2. See here a sum of two function will be obtained. The sum of these two, f of x and g of x, the value is e power x. Now it doesn't get the value of here f of x and g of x in the first equation. Now again one more condition is there. Now I am going to substitute that in equation 1. The second condition is there, again given. The second condition, y equal to 0 and the derivative dou z by dou y equal to e power minus x. Now going to substitute this one in equation 1. But your equation 1 is a function in terms of z is there now. Now I wanted to extract z in terms of y. That means if you want in terms of a derivative, if you want a derivative of equation 1, I have to differentiate that one with respect to y partially. If a differentiation of the one with respect to y partially, we have dou z by dou y. Here f of x is constant, you keeping f of x as it is, then e to the power of y, differentiation with respect to y, again e power y, then plus g of x is constant, the differentiation of e power minus y, the negative will appear here, it become a minus of e power minus y. So this is the derivative obtained for the second condition. Now apply this condition, if y equal to 0 and dou z by dou y value is e power minus x. Now I am going to substitute here, this is e power minus x equal to, the e power 0 value is 1, we have f of x minus g of x. Now call this as an equation number 3. So now we obtain a simultaneous equation, equation 2 and 3 are a simultaneous equation. Now using this equation 2 and 3, I have to extract the value of f of x and g of x. See, if addition of 2 plus 3, we get a one type of value. If addition of 2 plus 3, both g of x will be cancelled. We have only f of x. See here, the addition of these two, solve equation 2 and 3. Solve equation 2 and 3. You can solve these two equation 2 and 3. We get one of the value g of x. That means first I am adding 2 plus 3. If addition of 2 plus 3 is here, the plus and minus, these two are cancelled. The addition of these two we get in LHS e power x and e power minus, both are different. Just we have to add it. We get e power x plus e power minus x, that should be equal to 2 times of f of x. You get 2 times of f of x. I wanted only f of x. Your f of x will be reduced to like that. Send it here 2 to denominator. We get e power x plus e power minus x divided by 2. It's an exponential. This exponential term we can express in terms of an hyperbolic function. Simply we can write as cos hyperbolic x. We can also write down the solution in this form, either keep the answer in this form. So this is the one value of f of x we obtained. It is the cos hyperbolic x. Similarly, again use the equation 2 and 3 to extract the value of g of x. So I am adding these two, we get this one. Now subtract equation 2 then minus of 3, just like 2 minus 3. If you go to subtraction of these two, LHS will get like that, e power x minus e power minus x. Now I am going to subtract 2 minus 3, e power x, then minus of e power minus x, that should be equal to, see here, the subtraction of these two, that means I have to multiply the entire term by negative value. This become negative, this is negative, this become positive. If you go to subtraction from this to this, we get in the both the cases we f of x will be cancelled, this become positive, g of x become a 2 times of g of x. It is a 2 times of g of x. If you multiply it by negative, this become positive. A plus and minus will be cancelled, but here not cancelled, we get e power x minus of e power x, and these two, sum of these two will give a 2 times of g of x. Now again I wanted to g of x. Here g of x should be equal to e power x minus e power minus x by 2. Okay. Now again I have to use the notation e power exponential term in terms of an hyperbolic function. We know that it is a g of x value is sine hyperbolic x. So these are the two solutions I have obtained in case of f of x and g of x. Now I am going to substitute both these f of x and g of x in equation 1. So that will give the required solution of a PDE for independent variables. Now see here. So now equation 1 becomes, now substitute f of x and g of x in equation 1. So this is the required solution. Now I am going to substitute here. Now the final z will be appear in this form. Your z should be equal to f of x value is cos hyperbolic x into e power y plus your g of x value is sine hyperbolic x into e power minus. So this is the required solution of this particular problem. It is z e power x, that is z equal to cos hyperbolic x e power x plus sine hyperbolic x e power minus x. So this is the completion of second problem. Similarly, I move to the next problem. This is the third problem I want to solve. It is a dou square z by dou x square. No, instead of this one, dou x square should be equal to a square z, and some condition will be given. When x equal to 0, z equal to 0 and derivative dou z by dou x, this value is a times of sine. So, this is the problem will be given. So, that is in differential equation when x equal to 0, in both the condition, initial condition z0, that is your dependent variable, and the respective derivative, that's value is a sin y. So, this will be given. So, again as usual start with solution. Before going to solution, just have to remember z is depends on which variable. So, this is the problem. So, here definitely your z, definitely it is a function of x. If the first order partial derivative is a function of x, then I am going to convert this one in terms of an ODE. So, as usual what we did in the previous two problems, I have to use the same condition. For ODE, this become d square z by dx square equal to a square z. You have to convert in terms of ODE. Now, apply the d operator by assumption of this one. Your d is simply d by dx. You have to assume this one. It becomes d square z. Now, send it here, minus a square z should be equal to 0. Then take a common factor, d square minus a square z equal to 0. Then auxiliary equation is, your auxiliary equation is d square minus a square equal to 0. Then d square equal to a square, then d equal to plus or minus root of a square, then d equal to plus or minus a. So, again here totally we have d, it is a second order derivative, d we have a and d equal to minus a. Two roots are up here. So, both the roots are real, but they are different. In this case, the complementary function will be obtained for this ODE C1. It is a function of x, you have to remember, e power ax plus C2 e power minus ax. So, this is the solution we have obtained z C1 e power ax plus C2 e power ax, particularly for ODE. Now, I am going to change this solution, this complementary function in terms of PDE. That means, just you have to replace this constant C1 and C2 in terms of a function y. So, that means the solution for PDE, simply I am writing here now z, this is the solution for ODE. Now, I am going to convert this ODE in terms of PDE by assumption of C1 and C2 constant in terms of another variable, that is in y, that is in f of y, then e power ax plus g of y, then e power minus ax. This is, you can call this as an equation 1. Now, what I am doing here now I am going to extract the value of f of y and g of y. If we are going to extract these two value, now use the your initial condition. What they given in the initial condition, I have to use here now. In the first case, as usual, I am taking the initial condition. In the case when two cases will be given. In the first case given z equal to 0 and x equal to 0. This is the first condition they given for this equation. Now, substitute these two in the first equation 1, then 0. This is your f of y, then e power 0 plus g of y, then e power 0 into. We know the value of e power 0 is 1, then 0 equal to f of y plus g of y. Now, call this as an equation number 2. Now, again use the second condition. What is the second condition they given? Again, the given condition is dou z by dou x a times of sin y and x equal to 0. This is the second condition they given. Now, I am going to substitute the second condition in equation 1. We need a derivative. And what is that derivative? Z in terms of x, partial derivative with respect to x. Now, to differentiate 1 with respect to x, we get like that, dou z by dou x, that should be equal to f of y. I have to write down f of y as it is because it is a constant. With respect to x, it is a constant. Now, differentiation of e power ax is a times of e power ax plus g of y minus a times of e power minus ax. If I am doing this one, differentiate partially with respect to x. Now use this condition. What they given this condition, you have to substitute here now. The derivative dou z by dou x, this value is a times of sin y. Then correspondingly, you have to put the a value of x equal to 0. This is a sin y. Now substitute here a sin y should be equal to f of y. Now again you have to put here a times of e power 0 plus g of y minus a times of e power 0. We know that the e power 0 value is 1. Now our remaining term is a into sin y should be equal to, this value is 1, a times of f of y minus a times of g of y. Here the term a will be common in all the equations. For that we are going to divide throughout the equation by, now divided by a both sides. I am going to divide the entire equation by a. The remaining term we have sin y should be equal to f of y minus g of y. Now call this as an equation number 3. See here, again equation 2 and 3 is a simultaneous equation. Now solve these two simultaneous equations, we can extract the value of f of x, f of y and g of y. Again as usual, add these two, 2 plus 3, we get one of the equation f of y. Then subtract these two, we get then another equation. Okay. Now solve 2 and 3. Solve equation 2 and 3. Now I'm going to solve the equation 2 and 3. If you go to evaluation of these two, first I am doing 2 plus 3. It's a simultaneous equation. Now adding again here 2, 3. If addition of these two, a positive value and negative value will be cancelled of adding this. We get this one. 0 plus sin y, we get only a sin y. Okay. Then it should be equal to addition of these two, f of y, we get 2 times of f of y. Now finally, we have f of y value is sin y by 2. The next, again I am going to extract this value of g of y. If you want to g of y, just have to subtract this from 2 to 3. If I am doing 2 minus 3, if I am taking 2 minus 3, so I have to multiply the equation 3 by negative value. So this becomes 0 minus of sin y, we get minus sin y. That should be equal to, then see here, a subtraction of these two, this become negative, f of y minus f of y, they become 0, g of y minus become positive, then g of y plus g of y, it become 2 times of g of y. Then finally after simplification, we get g of y equal to minus sin y by 2. Now I got the value of f of y and g of y. Now after that, if you are obtaining f of y and g of y, now going to substitute in equation 1. That is equation 1 is z. So I have to change the arbitrary functions in by using these two solution, we get solution. Equation 1 becomes, now equation 1 becomes, I have to simply write down z equal to f of y, the value of f of y is sin y by 2 into the remaining term e power ax plus, then g of y, it is a minus term, it is a minus of sin y by 2 into e power minus ax. If we want to write down the further simplification of this equation in terms of hyperbolic function, by take a common factor of sine y by 2 from these two equations, we get z equal to, we take a common factor of sine y by 2. The remaining term we have e power ax minus e power minus ax. For writing the hyperbolic function, it needs 2 also, then e power ax minus e power minus ax by 2. We know that the value of e power ax minus e power minus ax by 2, it is in sine hyperbolic function. Simply you can write down z is sine y into sine hyperbolic ax. So this is the required solution for this particular problem. Then you move to the next problem. You can put a bracket for this. So next problem. So again, some different initial condition they given for this one. We'll take on the fourth problem. The initial condition will be changed here now. Dou z by dou x square a square z, and x equal to 0. When x equal to 0, your dou z by dou x, this value we treated as a sin y. Then dou z by dou y, this particular value given as a 0. This is the fourth problem. Again, as usual, to remember the problem what they given z, it is again it is in terms of f x, it's a independent variable. Then as usual you can convert this term in terms of ODE. Then after that write down the solution in terms of PDE. Then again using the initial condition you can extract the constant terms. Okay. Now take the solution. Here z is a function of x. You convert in terms of ODE, this becomes d square z by dx square minus a square z equal to 0. Again, where your d operator, they become d by dx. The assumption of this one, we get d square z, a square z should be equal to 0. Here d square minus a square z again equal to 0. Your auxiliary equation, I need an auxiliary equation. We can convert d in terms of some other variable m, whatever you want, I can change it. But I keep the answer in terms of d also. D square minus a square equal to 0. Again, d square equal to minus a square, it's become a plus. Then d equal to, it is a plus or minus square root of a square. Then again d is plus or minus a. Again, we have a d as a two roots. One is plus a, the other one is minus a. Here both it is a real roots with different form. Then the solution as usual in terms of z, it is z is c1 e power ax, then c2 e power minus ax. Because z is a function of x only, and also solution is also obtained in terms of x only. So this is the solution for ODE. Now I am going to convert this ODE in terms of PDE by assumption of C1 and C2 as an arbitrary function. So that is the other function is a y. You can change this one in terms of y. We get z equal to, it is an f of y e power ax plus g of y, then e power minus ax. Now again call this as an equation number 1. Now again use the initial different initial condition will be given here. Again use the condition, then I have to extract the value of f of y and g of y. Okay. Now in the first condition given, In the first condition, if x equal to 0 and dou z by dou x equal to a times of sin y. This is the first condition will be given. Now substitute in equation 1. So before substitution of this condition of equation y, I wanted to the first order partial derivative in terms of x. That means I have to differentiate 1. We get dou z by dou x. If I want to differentiate this one with respect to x, f of y is a constant, then a into e power ax plus g of y I have to keep as it is, then minus e power minus ax. Now substitute this condition, a sin y should be equal to, now substitute here f of y, a into e power 0 plus g of y minus e power 0. We know the value of e power 0 is 1. Again I have to integration, this one is a. Then a sin y equal to a into f of y, then minus a into g of y. Now divide throughout by a. We get, we want to divide throughout by a, sin y equal to f of y minus g of y. Now call this as an equation number 2. So if I are using the first initial condition, we get the solution in terms of like that. Is one of the equation will be obtained, that is f of y minus g of y equal to sin y. Then after that, one more condition is there now, or the second condition, again given second condition, x equal to 0 and dou z by dou y equal to 0. This is the second condition will be given. For this, use the z and extract the value of dou z by dou y. That means I have to differentiate equation 1 partially with respect to y. If we want to differentiate this one partially with respect to y, we get dou z by dou y. With respect to y, here e power ax is a constant, but this one will be differentiated like that. F dash y, then e power ax plus then g of g dash y into e power minus ax. After differentiation, we get like this. Then after that, now substitute these values here. Your dou z by dou y value is 0. Then we have f dash y, then e power 0 plus g dash y into e power 0. We know the value of e power 0 is 1. Then we want to substitute here now. We get like this. 0 should be equal to f dash y plus g dash y. One thing you have to remember here, in equation 2, we have a solution equation obtained in terms of f of y and g of y. But here we get the solution in terms of a derivative. I have to reduce the derivative in terms of f and y. If we go to the differentiate form is there now. Now to reduce the differentiate form in terms of f of y and g of y. If you want that, integrate both sides. Integrate with respect to y. So I have to do like that. If you go to integration of this one, this become f of y, derivative, it is a reciprocal. The derivative will be changed as an f of y plus g of y. It appears as some constant, I call this as an k. Now call this as an equation number 3. No, obtain like that. So here I have to remember one thing. So when x equal to 0 and dou z by dou 0, we extract the dou z by dou y by using an equation 1. We get the solution in this form, f dash y e power ax, because it's a constant, g dash y e power minus ax. Now use this condition, dou z by dou y is a 0. When x equal to 0, you put here x equal to 0, we get e power 0, e power 0. We know the value of e power 0 is 1. Then after that, the equation reduced to 0 equal to f dash y plus g dash y. Okay. Then you have to integrate this one with respect to y, because y I am going to integrate this function, I have to match this equation in term with 2. In both the cases we have f of y and g of y. That is the solution we have to need here now from these two. Okay, now we call this an equation 3. Now after that, solving equation 2 and 3, we extract the value of f of y and g of y. Okay, and so I have to understand why I am going to f dash y and g dash y have to reduce in terms of an f of y and g of y, because I need the solution of f of y and g of y. That's why I want to integrate this one. Now solve equation 2 and 3. Now solve equation 2 and 3. Now I'm going to evaluate these two. We go to evaluation of this one as usual what we are used in the previous 3 problems. Now I'm going to addition of 2 and 3, we get a one type of solution, then subtraction of other, we get the another type of solution. Now I am going to add 2 plus 3. So here 3 is there now, here 2 is there now. Addition of these two. If you go to addition of these two, see here g of y will both are cancelled. We get only this one LHS time, we get k plus sin y should be equal to 2 times of f of y. Then f of y should be equal to k plus sin y, then whole divided by 2. Now addition of 2 plus 3, we get a one type of solution, that is we get the value of f of y. And similarly, we are going to subtract 2 minus 3, that means we get another set of a solution. So I am writing here now. If we go to 2 minus 3, so again equation 2 is there now, sin y, then minus of this one, we get minus k LHS term should be equal to, if we go to negative of this one, this is minus f of y, this minus. Now addition of these two, 2 minus of 3, we get minus times of 2 times of gy. I have to remember this one, this minus of this, and those go to multiplied by negative value for this, it is minus f of y minus g of y minus k. Okay, then sin minus k, then this minus of this both are cancelled, then this become a negative, that is minus 2 times of gy. Then after that we get gy should be equal to sin y minus k, then whole divided by minus 2. So this is the value we are obtaining g of y. Now after getting this, we are going to substitute f of y, then g of y in equation 1. Now equation 1 become now I am going to substitute equation 1 becomes your z should be equal to your f of y k plus sin y, then whole divided by 2 into e power ax minus sin y minus k divided by 2 into e power minus ax. So this is the required solution for this particular problem. Okay, so just now I completed only 4 problems. So in the next class we are going to solve some more problems with the different initial conditions. Okay, so before going to this, we have to summarize what are the things we are discussing here. So here we are going to find out the solution of PDE for independent variable as a homogeneous independent function. So as usual, what the given problem, so PDE you have to convert in terms of an ODE, then after that you extract the solution in terms of ODE, that I have to change that ODE in terms of an PDE by assuming an arbitrary constant as in a function. So using the initial conditions, they have to extract the values of f of y and g of y.